This is Britt Caswell with another example video. In this video, I'm covering example 2 from section 3-1 in the SavvasRealize Algebra 2 textbook. In this video, we are looking at understanding the end behavior of polynomial functions. So, as we were talking about a little bit in the last video, we can determine a lot about a function if we know the leading coefficient, which is the very first number that appears in a polynomial in standard form, and the degree, which is the highest exponent of the polynomial. Now this table I got online. It's not part of Savvas, but it really helps us to recognize some of the patterns. Alright. Now the first thing that I do is I always look at the leading coefficient and whether it's positive or negative. And what the leading coefficient does is it actually tells us as we move towards the right-hand side of the graph, it tells us whether you're going up or down on your graph. So if you notice, when you have a positive leading coefficient, your graph is going to go up on the right-hand side. If you have a negative leading coefficient, your graph is going to go down on the right-hand side. And so you can kind of see that here in the examples, right? So here our leading coefficient is 1, 0.9, and 2. And on all of these graphs, when you go to the right-hand side, they're going up. Here our leading coefficient is 1, 0.5, and 2. And again, all these graphs are trending upwards. Here we have a negative 1, negative 0.9, and a negative 2. And on the right-hand side, these graphs all trend downwards. And the same thing here, all these ones are negative, and on the right-hand side, towards positive infinity, they're all going down. So then, to determine what the left-hand side of the graph is going to do, we look at the degree. So if the degree is even, your arrows are going to match. They're going to go in the same direction on the left and the right. So here I have degrees 2, 4, and 6. Those are all even numbers. So the left-hand sides are all going the same direction as the right-hand side went. Again, 2, 4, and 6. The right-hand side went down, so the left-hand side here is all going down. Now if you have an odd degree, so your exponent is an odd number, then the left-hand side of the graph is going to do the opposite of what the right-hand side of the graph does. Alright, so here we have 1, 3, and 5 for our degrees. So since the right-hand sides all went up, the left-hand sides are all going down. And the same thing here, we have the degree 1, 3, and 5. So where the right-hand sides went down, the left-hand side goes up. Alright, so let's go ahead and let's take this concept to talk about this notation that's here. Sorry if it's a little bit blurry. So what this is saying, it says, as x is approaching infinity. Okay, so remember on the number line you have negative infinity here on the left and positive infinity here on the right. So when we talk about as x is going towards infinity, okay, that's what this arrow means, is it's the word approaching. I'm going to put that here. Alright, so as x is approaching infinity, f of x, which is the y-axis, it's going to be asking whether it's going towards positive infinity or negative infinity, okay? So on the y-axis, negative infinity is down here, and positive infinity is up here. So this statement says, as x approaches infinity, f of x, so the y value, is approaching infinity. And you can see that as I come to the right on the graph, these lines are going up. Down here, for example, as x is approaching negative infinity, so as we are coming to the left here, f of x is approaching positive infinity. So you could see where the y values are all increasing. They're going upwards. So this is some notation that we use all the time. So let's go ahead and let's take a look at this. So we have this big, huge polynomial, which seems really intimidating. But remember, all that we care about is this leading stuff. Alright, that first part. So first we check out our leading coefficient. Our leading coefficient is a 2, which is a positive value. So our leading coefficient is positive. So that means that the right-hand arrow is going up. Our degree is a 6, which is even. So if you have an even degree, the left-hand arrow has to match. So this one's going to be an up, up polynomial. Now, if I wanted to use that notation that I was showing you just a minute ago to describe it, I would say as x approaches infinity, f of x is approaching, well, this arrow is going up, so it's also approaching infinity. As, having a hard time to write this this morning, as x is approaching negative infinity, f of x, so as x is going to the left, f of x is also increasing, so it's also going towards positive infinity. So let's go ahead, let's try one more. So again, we only care about this first term. So my leading coefficient is negative. So my right hand end behavior is going to go down. And my degree is a 3, which is odd. So my left hand arrow with an odd degree has to go the other direction. So since my right hand arrow is going down, the left hand has to go up. So if I want to describe the end behavior, I would say as x is approaching infinity, f of x is approaching. So as we go to the right, that's where infinity is, f of x is going down. So it's approaching negative infinity. And then as x is approaching negative infinity, so as x is going to the left, our y value, f of x, is going up, so it's going to go towards infinity. So there you have it. That is how we understand some of the end behavior of polynomial functions. Until next time.